In this last video for this section, we're going to use reference angles as well as the signs of the trigonometric functions to evaluate the angles or the value of a trigonometric function at a specific angle. And remember, a reference angle is just going to be the angle formulated by the x-axis that kind of completes or that basically completes that angle with the respect of where it terminated in the quadrant, okay, with the x-axis. So let's first of all remember we have our all students take calculus. And again, something that's going to be helpful is for us to memorize this table, okay? So if we have this table memorized and we also have the all students take calculus, then what we can do is we could just use those two in conjunction to be able to find the values of our trig functions. So we have cosine of 330. Let's first of all graph 330. Okay, so we know 330 looks something like this. It's almost 360. Okay, so this is 330 degrees for theta. And theta prime is going to be equal to the remainder. Okay, so basically, what does it take for us to get here? And that would be 360 minus 330, or 30 degrees. All right, so what that means is that the cosine of 330 is really either plus or minus the cosine of 30 degrees. All right, and that's where we go back into that table and remember that the cosine of 30 degrees, okay, from the table is going to be the square root of 3 over 2. So this is going to be plus or minus root 3 over 2. All right, now the question is, which one is it? Is it positive or negative? And so that's where we look and we notice that in quadrant 4, where the reference angle is, the cosine function is greater than 0. And so it's going to be positive. Okay, so that's just going to be root 3 over 2. All right, now, of course, we want to check this. And a way to check it is to go into your calculator, make sure you're in the degree mode, okay, and type in the cosine of 330. All right, let me clear this out. So the cosine of 330 degrees is 0.866025, blah, blah, blah. And then just type in the square root of 3 over 2. Right? And if you type that in, you get the exact same number. Okay, so that might be a way to make sure that you've done this correctly, is just type those both in, okay, and you should end up with the same value. Okay, you can also check the sign too, because that'll give you the positive or negative. Cotangent of 120 degrees. Okay, so we have our all students take calculus, and we know that 120 degrees is going to be a little bit more than 90. All right, so this is our theta equals 120 degrees. Theta prime then is going to be the rest of that angle. Okay, so this right here is going to be theta prime. And to figure that out, we're just going to take and subtract that from 180. So 180 minus 120 is going to be 60 degrees. And what that means is that the cotangent of 120 is going to be the same as plus or minus the cotangent of 60 degrees. Right? Now, at this point, we probably don't know the cotangent of 60 degrees from the table, but we know that the cotangent is the reciprocal. That should say reciprocal, sorry. So that's the reciprocal of the tangent of 60 degrees. So let's figure out, first of all, what's going to be the sine of this, okay? And we'll terminate in quadrant 2. Only the sine function is positive, okay? So it's going to be negative, okay? Because the cotangent function is going to be less than 0 in quadrant 2. Right? Now, let's try to remember what the tangent of 60 degrees is. Okay, so that's where we can go up to our table, and we're going to see that it's the square root of 3. Okay, so the tangent of 60 degrees is the square root of 3. Okay, and again, we go up to our table, all right, and we can see that right here. Okay, so we just memorize this, or we can try to derive it by using that trick that I showed you in the previous video. Okay, but we don't want root 3. We want the reciprocal. And remember, this is negative, okay? Because remember, our answer is going to be negative. And so this is actually going to be negative 1 over root 3. So that's going to be the cotangent of our 60 degrees. And remember, this is minus the opposite because and it's really the reference angle. And if we rationalize it, we multiply by root 3 over root 3. So this is going to be negative root 3 over 3. All right, now what we should probably do is check this in our calculators. All right, so we're going to check, and we're just going to clear this out, and we're going to say the cotangent of 120 degrees, which is 1 over the tangent. Okay, so this is going to be 1 divided by the tangent of 120. Now that gives us negative 0.557, etc. Okay, so let's see if that's the same thing as negative square root of 3 divided by 3. And wouldn't you know, it's the same thing. So that's how we can check to make sure that we're right on track with this, right? So another example, cosecant of 480. Now 480 clearly is outside of our 0 to 2 pi or 0 to 360. So we have all students take calculus. All right, let's go ahead and see if we can figure out what the reference angle is going to be. All right, so what we're going to do first is just go all the way around, and that's going to be 480. So 480 minus 360, right? And that's just going to give us 120. So we're going to go around another 120. And that actually ends up being the exact same reference angle as we did last time, okay? Because if we have 120 degrees, then what we're going to do is we're just going to subtract that 120 from 180. And so our theta prime is this angle. So that's 180 minus 120, which is going to be 60 degrees. All right. So realistically, what we can say is that this is equal to plus or minus the cosecant of 60 degrees. All right. Let's figure out what the sine is going to be, and it ends up in quadrant 2. All right. So we look at quadrant 2. The sine function is positive. That also means that the cosecant function is positive. Okay, so it's going to be positive just because it ends up in quadrant 2. We don't know the cosecant, but we certainly know the sine. And so this is going to be 1 over the sine of 60 degrees. And again, we're using the positive version of that. If we go into our table, this is actually going to be 1 over root 3 over 2. Right? Or if we multiply by the reciprocal, that's going to be 2 over root 3. And then if we multiply that by root 3 over root 3, that should be 2 roots of 3 divided by 3. And again, we could check this by using our calculators. So we just type in 1 over sine of 480. Okay, so in our calculators, we have 1 over sine of 480. All right, so that's 1.1547, da, 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 da. And then our answer was 2 roots of 3 divided by 3. And we get, once again, the exact same number. Okay, so again, that's a way for us to check to make sure that we have the right answer. Okay, just verify in our calculator, but also the correct sign. Okay, S-I-G-N. Okay, all right, we have sine of 11 pi 6. All right, so we construct 11 pi 6 by multiplying by 180 over pi. Right, that's going to cancel out. We know that 180 divided by 6 is going to be 30. And so 11 times 30 is going to be 330 degrees. Right? So really, this is going to be the same thing as the sine of 330. Now let's construct 330. And 330 is just about 2 pi, or just about 360. And so what that means is that we're going to end up with this as theta prime. Okay. To find theta prime, we know that all the way around would be 360. So theta prime is going to be 360 minus 330, or 30 degrees. Okay. So what this means is that we really have the same thing as plus or minus the sine of 30 degrees. Remember, all students take calculus. Okay. only the cosine function as well as the secant function are greater than 0 in quadrant 4. So it's going to be the negative version of that. Okay. Last thing we do, we just go through and remember in our table that the sine of 30 degrees is a half. Okay. And so this is going to end up being negative 1/2. All right. Now, once again, if we don't trust it, we could just go into our calculator and clear all this out. We can go to radian mode and we can type the sine of 11 pi over 6. And wouldn't you know it, it gives us negative 0.5. Okay, or if we need a fraction, negative 1/2. And that's precisely what we got here. Right. A couple more examples really quickly. The tangent of 4 pi thirds. All right, so once again, multiply by pi over 180. Right? We know, or I'm sorry, 180 over pi, excuse me. All right, so pi over 180 or 180 over pi. All right, those cancel out. 180 divided by 30 is 60. 60 times 4 is going to be 240 degrees. So really, we're looking at the tangent of 240 degrees. Right now, 240. We have 180, and then we have a little bit more than that. Okay, so this is going to be theta equals 240 degrees. The reference angle is going to be what we need to go back right here. Okay, so this is going to be our theta, and so that's going to be 240 minus 180, or that's going to be 60 degrees. Okay, so that means that the tangent of 240 is either plus or minus the tangent right now of 60 degrees based on what our reference angle is. Okay. Now we should go back up to that table and we should probably remember that the tangent of 60 is going to be the square root of 3. All right. So this is either going to be plus or minus root 3 because we have that table memorized. And then we remember that all students take calculus. The tangent function is positive in quadrant number 3. And so it should end up being positive square root of 3. Right? Now, let's just type it in our calculators just to verify. Tangent of 4 pi thirds. So we have our tangent of 4 pi over 3. All right. And then the answer was the square root of 3. All right, trying to find the parenthesis. There it is. And it doesn't matter. All right, you hit enter, get out of that. And we have the square root of 3. And notice that this value is positive 1.73205. 1.73205. It's the exact same thing. All right, so it seems like we're right. Last one we have is the secant of 13 pi fourths. Again, multiply by 180 over pi. Pi's cancel out. That's going to turn into 45 degrees when we divide it out. And then, or we could just type it into our calculators. So remember, we can use that trick 13 times 180 divided by 4. So in our calculators, we could do 13 times 180. And then we could divide it by 4. All right. And that's going to give us 585 degrees. Okay, so this is really the same as secant 585. Right? To plot 585, right? Well, we know that we have to go around at least once. Okay, and 585 minus 360. Okay, and we just go into our calculator and we subtract that out. Okay, so enter, and then we can subtract out. We can take 585 minus our 360. All right. Let me clear that out. So 585 minus 360. That gives us 225, right? And so what's left is for us to plot 225. Now 225 goes around. That's 180. And then we need a little bit more than that. So this should be our angle theta equals 585 degrees. All right. The reference angle is going to be the angle formulated by the positive x-axis. So it's going to be this. So theta prime is going to be equal to 225 minus 180, and that just happens to be 45 degrees. All right. So what that means is that the secant of 585 is either plus or minus the secant of 45 degrees, which is really the same thing as plus or minus 1 over the cosine of 45 degrees, right? Now, let's go ahead and go back to our table. Okay, so again, it's helpful to have this memorized. Okay, but if you don't have it memorized yet, it's root 2 over 2. We just go all the way back up to that table, and we have the cosine of 45 root 2 over 2. Right, so going back down here, if we had this memorized, it's a lot faster. So this is either going to be plus or minus 1 over the square root of 2 over 2, which is the same thing as plus or minus. We multiply by the reciprocal, 2 over root 2, and then we go ahead and rationalize it by multiplying by root 2 over root 2, plus or minus 2 roots of 2 over 2, or plus or minus the square root of 2. Now, last thing we do, all students take calculus. Only the tangent function is positive in this quadrant, so we have to go with the negative square root of 2. Of course, we should check this by taking 1 over the cosine of 13 pi fourths. Okay, so in our calculator, let's clear this out, and we're going to say 1 divided by the cosine of 13 pi over 4. All right, now that gives us a negative 1.414, blah, 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 blah. Okay, and if we were to just take our answer, which was negative square root of 2, we just say negative square root of 2. All right, there we go. We get the exact same thing. Okay, so that's just a way to check all these. Okay, but another way for us to be able to use our reference angles. All right, so this concludes being able for us to evaluate trigonometric functions. And there's 3 ways we can do this now. Okay, so remember in section 4.2, we had the unit circle. Okay, we had our right triangles. And then the other way that we can try to be able to evaluate these is to be able to use reference angles. Okay, so it should be that at this point, we should be able to use these pretty fluently, okay? Because from now on, what we're going to be doing is we're just going to basically say that if I ask you to be able to evaluate something like the sine of 480 degrees, you should be able to do that without going back through like any videos or anything like that, okay? So you should be able to do that and getting the exact value. Okay, it might take you a minute or two to do that, but you should be able to do this because the next stuff that we're going to be doing is all contingent upon your ability to do something like this. Okay, so if you're unable to do this at this point, okay, what you should do is go back through the videos, maybe practice a few of these, just make some up, okay, or go to the My Math Lab or go to the textbook and just pick out problems. That way you can make sure you can do these before moving on to graphs and then inverse functions and then applications, which are going to be the next sections of what we're doing in the course.